Okay, so here we are. This is AP Stats. First thing, what is statistics? The science and art of studying variation. You're collecting, analyzing, and drawing conclusions from that data that you collect. When you take notes, I would want you to know the red words there, like those are the big ideas here, an individual. That's who you're studying. It can be people, but it also could be a car or an animal or something else. So individual is just who you have, the objects you're studying. Could be people or other things. A variable is an attribute of that individual, right? So there are two types of variables. Categorical, you put things into categories. We'll see what that looks like in a minute. And quantitative, which are numeric. Think of those as a count or something you measure. Um, usually quantitative is numbers and categorical is words, but sometimes that gets a little fuzzy. Okay, so again, two types of those. There are two types of quantitative or numeric variables there. So one is discrete. There is gaps in between each number. So sometimes that happens with rounding. If you're, measuring distance by feet and you're not putting decimal points, that's a discrete variable going from 2 feet to 3 feet to 4 feet to 5 feet. But continuous, you could measure pounds to the, whatever decimal place it goes to. So 58.59732, whatever. Like it's continuous if you don't have any kind of rounding there. No, there's no kind of counting from one to the next. It's just a continuous variable. Okay, so distribution is and we use this word a lot talking about just the distribution of the data here. So oftentimes we'll represent this as a graph of some kind. Sometimes it's a table, but how often it takes that information. So here's a table of data here. And so you can see like what are the subjects does it look like is being studied here. So the subjects actually look to be the province, or let's see. I don't know, we don't have enough information about this, but it looks like maybe a person from Saskatchewan, which is a province in Canada, and maybe another person. So these are 1, 2, 3, 4, 5, about 10 people from Canada, chosen hopefully randomly. We'll talk about that later on. So preferred communication, they prefer a certain type of communication there, and that is definitely categorical. Some people like in person, those are not numeric, those are not quantitative at all, so those are easily classified as categorical. You can make a bar graph of categorical information. So bar graphs, you see these bars are separated. There's a little gap in between them. It doesn't really matter which one you put first. You could put cell phone first, but I could have put text messaging first. There's no rhyme or reason. You could put them alphabetical. You could do really however you want to as far as the order of categorical variables. On the left side, you can see the number. That's the frequency of how often those things happen. So in this case, there were 2 people out of that group chosen of Canadians that said that cell phone was the best way to communicate. Quantitative would be like number of languages. It's obviously a count of some kind. That is discrete in that it is not continuous. You can't really know one in a little bit of a language is either, this chart certainly is listed as whole numbers there. So this is definitely quantitative and it's a discrete type of quantitative. These can be represented with a dot plot. So you'll see these, the calculator does this really well. TI Inspire does, where we'll start with data on a table and we'll convert it to a dot plot. And you kind of see that it's actually skewed right there. There's one little outlier there at 4. We'll talk about what that is later on. How to analyze data. So oftentimes we have a table of data. We start with our graphs. We like to draw graphs. And then from there, we might add some kind of numeric summary. That might be the mean, median, standard deviation, mode, all those kinds of measures of center and spread that we might talk about later on. So this is just a big picture look at statistics, descriptive and inferential. So descriptive is what we're starting with in this chapter, which is, we're analyzing data, we're coming up with means and medians and modes and things about that data. Inferential is really what we're going to do a lot second semester, but we're going to draw conclusions from that, from the data that we're collecting. And so the idea is you start with a population of folks. It might be, a population could be all of St. Mary's students or something like that. And then we take a sample. It's important to take a sample that's representative of the group. And so hopefully if you sampled, you might sample maybe some from each grade, et cetera, but you're trying to take a sample. You collect data from that sample. Do you like Taylor Swift or not? Whatever it is the question. And then you're going to perform some data analysis on that. What percent of students like Taylor Swift? And then make an inference about the population. So, 67% of students like Taylor Swift of the sample, right? So then you might assume that maybe 67% of the population of St. Mary's students would like Taylor Swift or something like that. So we take a smaller sample and we assume or hope, we infer that that same percentage might hold true with the population. As long as we took a representative sample, it's usually going to be somewhat accurate. Okay, let's go to the next part here, at least kind of review this. So let's make sure you're all getting this. So Mr. Starnes is thinking about buying a new car. He's narrowed down the choices to 10 vehicles. Here are the information about each vehicle. So who are the individuals in this data set? So who are the individuals here? So individuals in this case would be the make of car, the 10 different types of cars we have here. I guess actually 10 different cars, I should say. So I guess that's the 10 different cars, 10 different cars that were chosen. What are the variables classified as categorical? So which ones are categorical? So categorical would be, engine type is categorical. That's easy, make and model are categorical. Drivetrain, certainly categorical. Number of doors. That, even though that's a word, that seems to be counting the number of doors. I think that's quantitative. Miles per gallon, quantitative. Price, quantitative. So I think we could say these guys are quantitative. So of those, which ones are discrete, which ones are continuous? So this one is definitely discrete. This one is also discrete because they're not getting decimals of any kind. It's being rounded for sure. And same thing here. These are all discrete because there's no decimals. There's no, you're going from one to the next. There are gaps between. There is probably some miles per gallon between 22 and 23 miles per gallon, so to speak. So they're not accounting for those gaps. So they're just skipping over those gaps. Okay, we got that. So now let's go to the next part. Okay, so we have this categorical data. And so when you have categorical data, those might be the values. In this particular, there are 10 different, 10 people from Canada that were interviewed about their preferred meshing type of communication. You could write these in a table. So there are two types of tables here. So one is called a frequency table. A cell phone, there were 2 people from Canada that said they preferred cell phone. There were 1 Facebook, 3 in person, and 4 text messaging. That's called a frequency table. How frequent was each of those 4 categorical options, variables there. In this case, relative, I think of as percentage. So those were just counts. How frequent was it? You could put these in proportions. Technically, 2 over 10 is the same thing as 20%, but typically you're going to see these relative, you're going to think of as, it's still a frequency table. How frequent was it? It was 20% of the time. That's 2 out of 10 over there. 1 out of 10, that's 10%. So it's just a different way of writing it. And typically, the more helpful way is relative frequency. I prefer that way. If I have a choice, it just helps me see the data as percentages a little bit easier. These are counts, those are proportions, and those are percents. Okay, so let's make a bar graph of the data. I want you to see what a bar graph looks like. So a bar graph, again, it has 4 separate categories, doesn't matter the order, the percent. So you can see this is definitely a relative frequency table because the y-axis there is written in percentages, and so that's a relative frequency table. If you do this with a pie chart, which is certainly another way to go, you can see that the size of the pie chart, so like text messaging was 40%, so that's 40% of this 360 degrees of that circle, whatever 40% of 360 is, the degree of that angle. So those were angles that were probably drawn with a computer and drawn exactly correct. So 10% would be 36 degrees there of that circle if you wanted to draw it accurately. And one thing that you may notice in both of these, nice labels. You notice that the label at the bottom, they both have a title to this thing. Inside of the pie chart has nice labels with percentages. Here on the bottom, the x-axis is labeled nicely, and then the y-axis also has the frequency in percent labeled nicely. There are good and bad graphs. So bar graphs can be a bit dull to look at times. And so sometimes, especially in the media, social media especially, you might see some more catchy, eye-catching graphs. And so this is an eye-catching graph. It's about computers. Previous computer, Macintosh, seems to be the most popular here. Number of buyers is about 350-ish. If you look at the top of that, compared to only Windows computer, less than 100 there. So you might say, wow, that's 75 times, I don't know, 5 might be that number of 350-ish. So, it's about 5 times as big, the Macintosh compared to the Windows. But what's the problem with the graph, right? I mean, do y'all see the problem with this? Watch the scales, right? The scale could be interesting, but in this case, the area of that computer, if you look, how many of those little Windows computers would fit inside of one Macintosh computer, according to the scale? Like 100, not 100, but a whole bunch, right? It only should be about 5 times as big. So having different widths, the heights seem to be correct for the graph, but the widths are really problematic. It makes this Macintosh look gigantic. And yes, it is 5 times bigger, but it's not 50 times bigger, which is what about it looks like there. We don't need that part. Oh, we're going to wait on that one, but I want to show another example of this. Okay, so let's make our own bar graph here. So here's the data, Spotify. So if you listen to music, maybe you're a Spotify listener. Frequency table summarizes the distribution of ages for the 100 Beatles listeners. Now, my guess is there are more folks, wow, I would have thought there were more folks over 50 who were listening to the Beatles, but maybe people over 50 don't have Spotify. I don't know what the story is here. There's a lot of information. Identify the individuals. So who are the individuals in this, and how many individuals are there? There are 100 Beatles listeners, right? So we would parrot back whatever it says. In this case, the sample was, we're sampling 100 Beatles listeners. We're hoping that we selected these randomly and they would be representative of the population, and we can make some inferences about the population potentially. So make a frequency bar graph. So here are the 3 things we have to do. So it says draw and label the axis. So let's just kind of do that first. So let's kind of draw and label the axis. So it looks like I need, so let me get this a little smaller here. So I'm going to have some different bars here. So this is 17 and under. This is 18 through 24, 25 through 34, 35 through 44, 45 through 54, and 55. Okay, the number of listeners, looks like I have at most about 33 listeners. So I'm going to go 10, 20, 30, 40. 40 is up there. So this is 30, 20, 10, and 0 there. Okay, so let's make our charts here. So 17 under is 5. So maybe something like this, roughly. That's 5. 25 for these guys. So all the way up to there-ish. Next one is 33, so go way up above the 30 there. 35 through 44, and these are supposed to be the same width. It might be helpful to have graph paper when you're making a bar chart. It would be helpful. 35 through 44 is 16, so somewhere in that neighborhood. 45 is 10, so right up to about there. And then 11, which is slightly higher, would be that. Again, these are supposed to be the same width. They're separated. You can fill them in if you want. Scaling is that second step I did. That's very important. Draw bars above the category names. I did that. So the one thing I might want to say is, put a title on this, like this is distribution of 100 Beatles listeners. And so that's a pretty good bar chart. Got my title. I drew and labeled the axis. Oh, did I label the axis? Okay, so this is number. This is the age in years. And this is the number of listeners. You can see it's good to, some people will draw it really nice, but then forget to label. I think that's probably the most common mistake. And then maybe just getting the scaling wrong or something. But that's not too bad. Really just don't forget, put a title, label the x-axis, label the y-axis. Those are all really good things to do. That's what they did here. They forgot a title here. I think they should put something in there about the title, but pretty good graph there. And that's done with the computer probably. Okay, just one example of this, maybe two. So this, what's wrong with this one? Similar to that last one, it looks like he has 1.6 steals and 6.1. So that's, I don't know, about 4 times as much, roughly. So, but you can see the area of this ball. If you took one of these guys and put it inside of there, there'd be a whole bunch, more than 4, 5, 6, 7, 8, 9, 10. Like the area is not, so a pictograph is a really bad way to do a scaling because it makes it look like so it's not a good representative graph. You want the same width there, and they don't have the same width. This is actually a pretty good example. It's from an actual newspaper from Kentucky. And it looks like when you see this chart, I saw this and I thought, wow, the Times has twice as much as the Daily Telegraph as far as the amount of people who take it, or get that delivered to their house or whatever it is. And in this case, the problem with the scale, you really always have to look closely at the scales. The scale starts at 420. Really, this scale should go all the way down to 0, way down here or somewhere way, way down there, probably even further down there is 0. If these bars, were actual bars and it went all the way down to way down there to where 0 is, you can see these bars are actually like almost the same size. I mean, there's definitely a little difference, but it's not a 50% difference. It's not twice as big. And that's by starting the chart at 420 instead of 0, it really kind of is deceptive. And you will find that anyone selling a product or advertising, they're trying to be somewhat deceptive. They're trying to make things appear a little bit more effective than they really are at, whatever it is. And so you have to be really careful with people, especially advertisers, will like to lie using statistics. And so they'll hide the truth in there sometimes. And if you're looking for it, you'll notice little discrepancies about how their work looks a little different than it should. Okay, so that is basically our first lesson of the year, this year. So that's all we got. And you'll have in your syllabus what problem numbers you have to do and so forth. Thanks.